Simple classes aren't the only parameter types you can specify for generics. There is a naming convention that is often adhered to. It isn't required by the language, it's only a convention. The first thing you'll notice about the convention is that all the names are made of single uppercase letters. You've already seen this one. In the previous example, it was used as the macro symbol representing a class with objects stored in a wrapper. This is for elements. This is the one you can see used a lot in the classes that are included as part of the Java Standard Library. You can tell by this category that the naming convention is more about how things are used than what they really are. In a later lesson, I will be showing you how to use more than one parameter. For multiples, the convention is to use letters that don't have another definition. But in truth, you can use anything you want. It just makes the code a little easier to decipher if you follow the conventions. You can use generics to apply to only a single method. It doesn't matter whether or not the method is inside a class that is also defined as a generic. In this example, the only thing generic in the class is this one method. Notice how the method is defined. The generic type has to be defined somewhere, so it can be just stuck in front of the definition of the method. It has nothing to do with the method type or its return value. It's just the place where you define the type variable name. When you call this variable, you can call it with any object type. Now these two methods are actually the same. The only difference is that the parameter to the genType method becomes whatever type is passed to it. And the OBJType method remains a method that accepts anything. It's a subtle difference, and the code that's generated by the two is the same. You can create an instance of a generic class so that it will accept anything. This object will accept anything that is a subclass of object, and every Java class is a subclass of object, so it will accept anything. As you can see, you need to cast the returned object. The executable code generated by this code is the same as it would be if the original class were not defined as a generic. This may seem like sort of the long way around to do nothing. However, I have needed to do this. Several of the standard Java classes have been modified and now they require generics, and I have been able to use this technique to compile some of my older code with the newer compiler. I'll have some more to say about this in the later lesson on gotchas. In the next lessons on generics, I will show you how to define generic classes that will work with families of classes.